Have you ever wondered what's really going on inside an AI's head when it makes a decision? You might think it's some kind of magic, but it's not. It's actually pure, cold logic. Today, we're going to pull back the curtain on the elegant system that allows a machine to know things, to reason about them, and ultimately to act.
So let's start with the biggest question of them all. How do you actually get a machine, a bunch of circuits and code, to act intelligently? How does it make sense of the world around it and then choose the right thing to do?
Well, the answer, and it's a huge concept in AI, is the idea of an intelligent agent. But not just any agent. We're talking about a special kind of agent that doesn't just react to things, but one that actually knows stuff.
And this is what we're talking about, a knowledge-based agent. The best way to think about it is as an AI that has its own internal library full of facts about the world. It's not just following a simple script. It actually holds on to knowledge, thinks about it, and then decides what to do. And that right there, the ability to reason over what it knows, that's the secret sauce. So if we could peek inside this agent's mind, what would we actually see? Well, it turns out you can really break it down into two main parts. You can think of it like a brain and a library. Okay, I know this diagram might look a little intimidating at first, but it's really just mapping out a thought process. Let's stick with that self-driving car idea. It perceives a red light. That's the input. That new fact goes straight to the inference engine. That's the brain, which then checks the knowledge base, the library, and finds the rule if light is red, then stop. And what's the conclusion? The car hits the brakes. Simple as that. That's the whole loop right there. And this slide just nails that separation, right? On one side, you have the knowledge base. That's the library. It's just a huge collection of facts, all stored as sentences. But what good is a library if no one's there to read the books? That's where the inference engine comes in. It's the brain that actually reads those facts, connects the dots, and comes up with brand new conclusions. Here's the thing, though. You can't just type plain old English into this knowledge base. A machine needs a language that's super precise, with absolutely zero room for confusion or ambiguity. It needs a formal language for knowing. So people in AI have come up with a bunch of ways to do this. You've got things like semantic networks, which kind of look like mind maps, and production rules, which are basically just a series of if-then statements. They all have their uses, but for what we're talking about today, we're going to zero in on the real heavyweight champion of them all. And that is first-order logic. Honestly, it's pretty much the gold standard when you need to express really complex ideas in a way a machine can actually understand and work with without any mistakes. And, just like English or any other language, first-order logic has its own grammar and vocabulary, a strict set of rules that let us build sentences about the world with total mathematical precision. All right, let's break down the actual building blocks. This table lays it all out. You've got constants, like John or cat. Those are basically your nouns, the specific things in the world. Then you've got variables, like x. Think of them like pronouns, just placeholders. Predicates, like brother or is greater than, they're your verbs. They describe how things are related. And those last two, connectives and quantifiers, well, they're the glue that holds all our thoughts together. So the most basic, fundamental thing you can state is what's called an atomic sentence. It's just one single, indivisible fact. So, for example, sisters Gita Sita is just a way of stating that a sister's relationship is true between these two constants, Gita and Sita. That's it. One fact. But of course, the world is way more complicated than that. So what do? We start building complex sentences by linking these simple facts together. We use connectives like and, that's that little upside-down V, or the regular V, and not. This lets us weave simple truths into a much richer picture of the world. Okay, now this next part is where logic gets seriously powerful. This is what lets us jump from talking about specific individuals, like Gita and Sita, to making these big, general statements about whole groups of things. And we do that using quantifiers. And there are really two main kinds you need to know. First up, you've got the universal quantifier. It looks like an upside-down A. This one means for all or for every. It's making a huge, sweeping statement that applies to absolutely everything in a group. Then you've got the existential quantifier, that backwards E. This one's more specific. It means there exists, or for some. It's just claiming that something is true for at least one member of a group. Okay, let's make this real. Here's a simple sentence we all get. All cats like fish. So how on earth does a machine read and understand that? This is what the machine sees. The translation uses that universal quantifier, the upside down A. You read it like this. For all things, we'll call them X. If that thing X is a cat, then that thing X likes fish. See that little arrow? That just means implies or then. It's a rock-solid rule, no exceptions.
Okay, let's try a different kind of sentence. How about this one? Some students like ice cream. Now, we're not talking about all students, right? Just some of them.
So the logical form for this one uses that backwards E, the existential quantifier. It reads, there exists some X such that X is a student and X likes ice cream. And check this out, we're using the and symbol here, not the implies arrow like before. That tiny difference is everything. This is why logic is so perfect for machines. It's just that precise.
All right, let's pull all these pieces together. We've seen the agent's mind, the library in the brain. We've seen the language it speaks, first-order logic. So now let's see how this whole system actually thinks and acts. So this is it. This is the thought process, the core loop that's happening over and over and over again. First, it senses something in the world, and that becomes a new fact. Step 2, it files that new fact away in its knowledge-based library. 3, the inference engine, the brain, kicks in. It connects that new fact to everything else it already knows and deduces something new. And finally, step 4, it chooses an action based on that new insight, and then the whole cycle starts right back up again.
So what's the big takeaway here? This logical structure is the backbone that allows an AI to reason about its world. It's a framework that lets an AI build a model of its world, draw new conclusions from it, and then act on them in a way that's totally logical, consistent, and, really importantly, verifiable.
And all of this leads us to a much bigger, kind of philosophical question. We've seen how an AI can follow these logical rules perfectly to act in an intelligent way. But does that mean it actually understands what a cat is, or what liking fish feels like? If it can reason logically, can it ever truly know? Something to think about.